Hello students, so today we will solve the CBSE 2022 physics board question which says a ray of light is incident on a prism at an angle of 45 degree and passes symmetrically as shown in the figure. Calculate the angle of minimum deviation, the refractive index of the material of the prism and the angle of refraction at the point P. So let us complete the diagram and see which is the deviation angle. So this is the path of the incident light ray, and if you retrace the path of the emergent light ray, so this light ray, this is the emergent light ray, if you retrace it backward, then angle found between these two paths, that will be the deviation angle delta. And also if you draw a normal at this point Q here, then the light ray, this light ray PQ, that is the refracted light ray, and beyond Q this is the emergent light ray. Now let us mark this as the refraction angle R1 and this as the angle R2. So now if you know the formula for deviation angle says that delta is equal to I plus E minus A, where I is the incidence angle which is given 45 degree here, and this angle will be emergence angle, and these I and E are equal when the ray will pass symmetrically, and this is the condition for minimum deviation. So when I will be equal to E, then the minimum deviation will be produced by the prism, and you can write this expression as 2I minus A. Now let's put the values. 2 times I is given as 45 degree minus A prism angle, this is given as 60 degree here, so let's put that also. So 45 to jar 90 minus 60, this is 30 degree. So first part answer is delta M, minimum deviation angle is 30 degree. So this was your part A. Now let's come to second part, part B. Part B says the refractive index of the material of the prism. So how will you find the refractive index of the material of the prism? So for that you need to use Snell's law. And Snell's law says that refractive index of the material of the prism mu will be equal to sine I divided by sine R. And what it will be, sine I means sine 45 degree as given in the question diagram. And what will be this angle R1? Actually this delta is 30 degrees, so you know this angle is 30 degrees, so this will be equal to sum of these two angles. And as ray is passing symmetrically, so this is total is 30 we have obtained, so each of this will be 15 degree. This is 15 and this will also be 15 degree, because exterior angle is equal to sum of the two far angles, and delta will be equal to sum of these two, and these two are equal, so each of them will be half of the total delta, means half of 30 degrees, so each of these will be 15 degree. So now this total is 45 degree, and this total vertically opposite to this will also be 45 degree, and if you subtract this 15 degree from it, then you will get R1 and R2 both as 45 degree minus 15 degrees, so it will be your 30 degrees. So refraction angle R is equal to 30 degree. Now let's put it here. So mu will be equal to sine 45 degree divided by sine R, means sine 30 degree. So we are putting this R here in sine R. So sine 45, if you know, that is 1 by root 2, and sine 30 is 1 by 2. So it will be 2 divided by root 2. So answer will be root 2. So mu refractive index of the material of the prism is root 2, which is 1.414. You can also write. And now the last part, third part of the question, see the angle of refraction at the point P. So that we have already found out. The angle of refraction at point P, that will be equal to 45 degree incidence angle total, minus this angle will be delta M divided by 2, and we have calculated this as 45 degree minus 30 degree divided by 2. So this is 45 degree minus 15 degree, and we found that is equal to 30 degree. So answer to third part is 30 degree. So this is the solution to the question. I hope you understood this. So thank you very much. Take care and bye bye.